All right, moving on to the 4-6 notes. All right, we're going to skip the construction of these angles, and I'm going to move down here to where it says congruent angles. So congruent angles are angles with the same measure. Again, I'm going to be using the congruent symbol, which is again an equal sign with a tilde above it, when we're making a statement about congruent angles. Also, in the diagram, when we're marking up congruent angles, we're going to use tick marks. So let's take a look at example number 1 here, where we are given angle A is congruent to angle B. So again, we're going to mark those up using tick marks. So angle tick marks are arcs, usually. So here we're going to mark up angle A is congruent to angle B. We talked about in the previous lesson that when you use 3 letters to name an angle, that usually means that at the vertex there is more than one angle. Okay, so we got to be careful in how we mark up the next congruent statement. It says angle APQ is congruent to angle BPQ. All right, so again, we're going to follow the letters from A to P to Q. So this is the angle that we're going to put a tick mark on. And then to distinguish it from the first marking we made, we're going to put 2 arcs. Okay, so that angle is angle APQ, and it's congruent to angle BPQ. So B to P to Q. So it's this angle that we're going to put a double tick mark. Okay, so those 2 angles are congruent. Angle AQP, AQ to P. I'm going to go ahead and mark with a triple tick mark. That's congruent to angle BQP. So again, because those 2 angles are said to be congruent, we're going to use the same tick marks to indicate that. All right, example number 2. They're asking us in part A to state the segments that are congruent. Okay, so again, we're looking for the tick marks for segments. As we can see here, we have similar tick mark right here for DC and DF. So for part A, we can say that DC, segment DC, is congruent to segment DF. Right. We also see the same tick mark here on DB. So we actually have 3 segments that are congruent to each other. So again, I could extend that congruency statement to include all 3 of those. And we also see another tick mark here on AD and ED. They have the double, so those 2 are congruent. So AD is congruent to DE. All right, let's see what you can do with part B. So again, we're seeing 3 angles that have the same tick marks. So we're going to have, again, an extended congruency statement, talking about all 3 of those angles being congruent. Again, because all 3 of those angles share D as a vertex, we must name all 3 of those angles using 3 letters. Part C is asking us to find the measure of angle ADB. ADB. Well, if we look closely at angle ADB, we notice that that angle is one of the ones that's marked up congruent. Okay, so we need to see if we can figure out a way to solve that measurement. And one way to do that is to kind of break down the picture. So here off to the right, I drew the angle FDC. Right? Because we know this is a straight angle, and we know that a straight angle measures 180 degrees. And then when I draw in segment AD, we know that at least on the left side of that segment, we have this symbol, which we know measures 90 degrees. So knowing that the straight angle that we had originally was 180, and that this angle right here is 90, so that means that the other side of that line segment must also equal 90 degrees. Right? Because those two angles make up the 180 degree angle. Right? So if the one on the left is 90, the one on the right also has to be 90. All right, but that's not the angle we were being asked to find. All right, we're trying to find angle ADB. So if we go back to the original picture, and I make that little right angle mark in there, so again, reminding us that angle ADC is equal to 90 degrees. Right. But again, that angle is made up of these two angles here that are congruent. So what does that mean for angle ADB? Well, if together those two angles make up a 90 degree angle, and both those angles are congruent, meaning they have the same measurement, that means they both have to be 45 degrees each. Okay, so that makes angle ADB measure 45. Let's move down to the next section dealing with complementary and supplementary angles. Complementary angles are two angles whose measurements add up to 90 degrees. While supplementary angles are two angles whose measurements add up to 180 degrees. All right, so looking at the examples for number 4, part A, those two angles will be complementary. I take that back. Those two angles will be supplementary because they add up to 180 degrees. Part B, those two angles will be complementary because they add up to 90. For part C, because angles 1 and angle 2 make up that 90 degree angle, you see there, right? That's 90 degree angle symbol. That's 90 degrees, so 1 and 2 are complementary. And for part D, 3 and 4 make up that straight angle. Straight angles measure 180 degrees, therefore, those two angles are supplementary. Let's skip over to example number 7. Here we're given an angle A and angle B are complementary, which we know that means they add up to 90 degrees. And we're given expressions for angle A and angle B. So we need to find the measure of angle A and angle B. So therefore, we need to solve for x. But we need to write an equation to help us do that. And because we know that angle A and angle B are complementary, we know that when we add their measures, they equal to 90 degrees. So we're setting up the plan. And then we're going to substitute so that we can have an equation to solve for x. So again, using the fact that they're complementary, we're going to set up the plan that angle A plus angle B equals 90 degrees, and then we're going to substitute the expressions for the measurements of those two angles. All right, again, when we solve for x, we get x is equal to 20. And so when we plug it in for x, we get angle A is equal to 72. Plug that in for B, we get angle B is equal to 18. So again, we're verifying that we did the math correctly. and because when I add those two up, they definitely add up to 90 degrees. All right, moving down, we're going to skip the constructions, moving on to more vocabulary. Perpendicular lines are lines that intersect to form right angles. Okay, the symbol for perpendicular is like this upside down capital T. As we're given here in example 8, we're given a segment RO is perpendicular to segment NP. So what can we conclude? Because RO is perpendicular to NP, we know, again, perpendicular lines create right angles. Again, at that point of intersection, at O, all right, that's where we have our right angles. So angle ROP and angle RON are right angles. Example 9, we're given segment MO is perpendicular to segment OP. So therefore we know that at the point of intersection, which is O, that there is a right angle. And to find the measurement, or to find X and the measurement angle MOR, we need to write an equation. Well, we know that these two smaller angles in here make up that right angle. So therefore, they're complementary. All right, so again, because they're complementary, we know that they add up to 90 degrees. So we can use this plan to set up our equation to solve for X. So here we got X is equal to 12. So we plug that in for X and we get angle MOR is equal to 43 degrees. All right, this last one, we're given an angle, segment AB is perpendicular to segment BC. And we know that there's a right angle there then, because perpendicular lines create right angles. And right angles measure 90 degrees. We got angle 1 and angle 2 that make up that 90-degree angle. So that means angle 1 and angle 2 are complementary. Which also means that angle 1 plus angle 2 equals 90 degrees. So now that we have our plan, we need to write an equation to help us figure out the measurements of angle 1 and angle 2. Well, additional information is given that angle 2 is 4 times the measure of angle 1. So if we let the measure of angle 1 have the variable x as its representation, so that means angle 2 is going to be 4x, because angle 2 is 4 times the measure of angle 1. So with that, we're able to do a little substitution into our equation. The measurements of those two angles, giving us an opportunity to find the measurement of angle 1 and then eventually angle 2. All right, solving for x, we get x is equal to 18, and then x represents the measurement of angle 1, so angle 1 is 18 degrees. When we plug 18 in for x, for angle 2, we get angle 2 is equal to 72 degrees. All right, again, we know that our calculations seem reasonable, because when I add those two angles together, they add up to 90. All right, that's it for today's lesson. Move on to the 4-6 homework.